Welcome to this video tutorial on the area of regular polygons. We're going to look at two problems in this tutorial. The first is pictured on your screen. Maybe you want to hit pause and try it out before we proceed. So first, we're just going to draw the triangle that we really care about. It's just the triangle involving the apothem of our regular polygon. It's the triangle that would really go from the center of the regular polygon perpendicular to a side and connecting with one of the vertices. If we were to draw in the entire regular polygon, which we won't, but if we were to draw it in, it would continue to the left, it would continue over like this, it would continue up like that, and this is the triangle that we care about. So now what we're doing is we're focusing on that triangle that we care about. Here's the apothem. Since the side length of the entire regular polygon is 10, this is half, which will be 5 in this case. Now in order to determine the angle, what we need to do is remember the formula for each angle of a regular polygon. From units previously, it's n minus 2 in parentheses times 180 divided by n. In this case, the n is 24, so we'll get 22 times 180 divided by 24, and we'll go to our calculator. So we go 22 times 180 divided by 24, and that would be each angle in the regular polygon itself, but we don't want the full angle. Look at our triangle. It's half of the angle from the regular polygon, so we have to split it in half, and that turns out to be 82.5. So over here, this was 165 degrees, but we recalled that we had to take that number and split it in half, so this turned out to be 82.5 degrees. Next, as we solve for the apothem, we've got the opposite side, we've got the adjacent side, so we will take the tangent. Tangent of that angle is equal to the opposite, which is the apothem, or A, divided by the adjacent, which is 5. Solving for the apothem, it's going to be 5 times the tangent of 82.5 degrees. We'll go back to our calculator. Please always make sure that you are in degree mode. So we'll come over here to mode, make sure we're in degree, and then we'll go back to the home screen, take 5 times the tangent of 82.5. That'll get us our apothem, which is about 37.98. I'm going to store that as A for the apothem, 37.98. Then we want the area of the regular polygon itself. So don't forget that the area of the regular polygon is 1/2 ASN, where the A is our apothem. We found that it was 37.98. The S is the length of the entire side. Watch out for that, it was 10. And the N represents the number of sides, which in this problem was 24. So we'll go back to our calculator and type that in. So it's going to be 1/2 times, you could even say the previous answer, which you go second negative sign to get the previous answer, times 10 times 24, and we're getting 4557.45. Make sure we put the correct units at the end. We're talking area involving centimeters, so that would be centimeters squared. That's how we approach the area of a regular polygon. We draw this key triangle, we use some trig, and we also use the each angle of a regular polygon formula to work out the final answer. One more problem we will look at in this tutorial, a problem like this. Perhaps you want to pause and try this out before we work it through. First up, we know the area of a circle is pi r squared. So we'll set pi r squared equal to 250. Now we need to get the r by itself, so we'll divide both sides by pi. And what we get is that r squared is equal to 250 divided by pi. Get the r by itself means take that square root, and what we will do is we will go to our calculator and type that in. So on our calculator, we're going to type the square root of 250 divided by pi. Please use your pi symbol. It's second, and then it's the exponent key right above the division symbol. Make sure to close your parentheses, and we get about 8.92. I am going to store that as alpha r because that's our radius of 8.92. Then, now that we've got our radius, we'll draw in that key triangle that we care about. It's a triangle right here that goes from the center of our regular polygon perpendicular to a side. Don't forget that this is the apothem. We need to figure out the measure of the angle involving that triangle, which would be the n minus 2 times 180 divided by n. Here, we've got a pentagon, so n is 5. And we'll work that out. 3 times 180 divided by 5. Let's go to our calculator. 3 times 180 divided by 5. 108, but that's clearly not a 108-degree angle. Remember, we have to split it in half. So divide it by 2, and we'll get 54. So this came out to be 108, but when we split it in half, we got 54 degrees. Now I'm also going to call the bottom part of that triangle x. So now we'll get a little involved with the trig. 8.92 is the radius. That goes from the center to the circle itself. So the 8.92 is the hypotenuse. One of the things that we can do is the sine of 54 degrees, which would be our opposite of A, divided by our hypotenuse of 8.92. So A is going to be 8.92 times the sine of 54. Keeping all the decimals is best. So if you keep all the decimals, we're going to take our, and then we're going to multiply it by the sine of 54, and that will be our new apothem. So we will store it as alpha A, 7.22. But then we also need to solve for x, which is the adjacent side. So we will use the fact that the cosine of 54 degrees is equal to the adjacent, which is x, divided by the hypotenuse of 8.92. Solving for x, it'll be equal to 8.92 times the cosine of 54. Going back to our calculator, we'll take the radius again, and it's that number times the cosine of 54. That's going to be our value of x, 5.24. But we want the full side length. Be careful. The full side length is double that. So we're going to multiply 5.24 by 2, and that's going to get us the side of our triangle. So doubling it, we will then store that as alpha s, and it's about 10.49. So now continue to be organized with your work and make it clear what you're doing. Next, we are going to calculate the area of our polygon, which is 1/2 ASN. Show what you're plugging in. So the A is the 7.22, the S is the 10.49, and the number of sides in this polygon was 5 because it's a pentagon. We'll go back to our calculator and we'll type that in. So it's 1/2 times our apothem times our side length times 5. Now sometimes it's good just to double check and make sure you use the right numbers. So it's 1/2 times 7.22 times 10.49 times 5. Notice how they're not exactly the same thing because we lost some of the precision and accuracy by rounding. Ideally, it's 189.21 for the area of our polygon. Now that's not our final answer because we wanted the shaded area. So last but not least, the area of the shaded portion will be the area of the circle minus the area of the polygon. Here, the circle was 250. The polygon was 189.21. And when we subtract those numbers, we will get our final answer for the shaded area. So we'll take 250, subtract our previous answer. You can go yellow, negative key to get that. And we're getting about 60.66. 60.66, the label, let's go back into the problem earlier, was square centimeters. This would also be centimeters squared. And that's how we would polish off finding the the shaded area involving this figure. So areas of regular polygons is just another way to be triggy.